Welcome to Summarize Science. Imagine trying to solve a puzzle with missing pieces. You have to make educated guesses to see the whole picture. In the world of data, this happens all the time, from incomplete medical records to unanswered survey questions. Scientists use AI methods to fill in these blanks, a process called imputation. But this paper asks a critical follow-up question. It's not just about filling in a value, but knowing how confident we should be in that guess. Is it a near certainty or a total shot in the dark? The researchers put several of today's top imputation methods to the test. They didn't just measure accuracy, but also calibration, a technical term for how trustworthy a model's self-reported confidence is. In other words, they checked if the models were being honest about their own uncertainty. And here's the core finding, which is a huge deal. The most accurate models were often the least honest about their confidence. Looking at these results, we can see this trade-off in action. A method called soft impute, for example, often produced highly accurate guesses, making it look great on paper. However, it was terribly calibrated, meaning it was consistently overconfident in its answers, even when they were wrong. Conversely, an older, simpler method called mice wasn't always the top performer on pure accuracy. But its calibration was excellent. It had a very realistic understanding of its own limitations. When mice was uncertain, it produced a wide range of possibilities, honestly reflecting its doubt. This calibration curve shows it. Mice's line is much closer to the perfect calibration diagonal than other, more accurate methods. Modern deep learning approaches presented a fascinating middle ground. A model named MiWi managed to strike a fantastic balance, achieving both high accuracy and reliable calibration. It makes good guesses and is also honest about its confidence. The catch? This high-quality performance came at a cost, as it was one of the slowest and most computationally expensive methods tested. So, let's recap the important points. First, accuracy and reliable confidence are not the same thing, and you often have to trade one for the other. Second, the best imputation method depends entirely on the task at hand. For high-stakes decisions, like filling in a missing value in a patient's lab results, you'd much rather have an honest, well-calibrated model that flags its own uncertainty. A model that confidently provides the wrong number could have dangerous consequences. This research provides a vital guide for practitioners to choose the right tool for the job, pushing us toward AI systems that are not just smart, but also trustworthy. Because sometimes, the most valuable answer an AI can give is, "I'm not sure."